We are on a collision course in mutual descent towards our neighboring large galaxy Andromeda. It's astounding what the James Webb Telescope learned about the Andromeda galaxy after hours of observation and data collection. The worrisome message from the Andromeda galaxy portends widespread calamity. When we look up at the night sky, everything may appear calm, yet appearances can be deceiving. Even though it may not seem like it, our Milky Way galaxy is actually traveling through space at a whopping 1.3 million miles per hour. More so, it is directly en route to the Andromeda galaxy, which is its nearest neighbor. Unfortunately, the two galaxies would collide, and chaos would ensue. Why is this epic war between our home galaxy and the Andromeda galaxy happening? How will this head-on collision affect our galaxy? Join us as we explore what is happening with the Andromeda galaxy and the signals received. Something occurred in a faraway galaxy 8 billion years ago, and the result was a tremendous explosion of radio waves that raced across space. Despite its brief duration of less than 1,000th of a second, an Australian radio telescope was able to receive the signal when it eventually reached Earth. This flash from the cosmos was a fast radio burst, a little understood phenomenon first discovered in 2007. According to astronomers, this fast radio burst was the most powerful and distant ever recorded, having traveled 8 billion light-years from a time when the universe was half as old as it is now. The precise origin of fast radio bursts is still a mystery to astronomers. A scholar at Harvard University even went so far as to say they might be evidence of extraterrestrial life, among many other explanations. Magnetars, which are the most magnetic objects in the cosmos, are believed by scientists to be the leading suspects. Ryan Shannon, an astrophysicist at Australia's Swinburne University, said it was mind-blowing that the RCAP radio telescope in Western Australia had spotted the radio burst. The exact causes of fast radio bursts are yet unknown. We were lucky to be looking at that little spot in the sky for that 1 millisecond after the 8 billion years the pulse had traveled to catch it, said Shannon, co-author of a study describing the find in the journal Science. The prior record holder was around 5 billion light-years distant, but the fast radio burst easily outshone it. The pulse was so intense that it unleashed 30 years' worth of solar energy in less than a millisecond. Hundreds of thousands of fast radio bursts might be flashing across the sky on a daily basis. Although their origin is critical to comprehending them, scientists have only been able to trace the origin to 50 of the about 1,000 that have been found thus far. The latest radio burst, designated as FB20220610A, was investigated using the Very Large Telescope in Chile. The peculiar magnetar may have been formed as a result of a signal emanating from a clumpy galaxy that was undergoing mergers with at least two other galaxies in space. Gravity can accomplish some very remarkable things, along with ensuring that your coffee lands squarely on your shirt here on Earth. The unseen power is also responsible for shaping space into spherical planets, transforming dust and gas into brilliant new stars, and smashing entire galaxies together. Gravity attracts galaxies, sometimes two or more until they collide, causing their contents to slosh and mingle, creating a giant galactic ball. At nearly every step, astronomers have observed these so-called mergers. At first glance, the cluster of galaxies looks like it's all coming together for some important cosmic meeting. When gravity has started to stretch them out of their natural shapes in the thick of it, and after all is said and done, a chaotic sphere is what is left. An updated picture taken by Hawaii's Gemini North Observatory shows the early phases of a merger with stunning clarity. The two galaxies, NGC 4567 at the top and NGC 4568 at the bottom, will take around 500 million years to swing around one another, jostling existing stars and igniting new ones. They currently resemble a tiny paper heart. Galaxy merging is one of the most intriguing cosmic phenomena. Black hole mergers and supernovae are both visually stunning, but that's not all you get when galaxies unite. Galactic collisions are also a terrific source of inspiration for daydreams about life on planets far from Earth. Take into account that NGC 4568 and NGC 4567 are rich in stars, and we know from observations of our own galaxy that the majority of stars have planets. That suggests that if we could indulge in a little fantasy, someone else may consider the NGC galaxies to be their home. What might it be like to live through a galaxy-wide merger? Our Milky Way is about to collide with Andromeda, the nearest spiral galaxy, and we wish it weren't frightening. Our galaxy and Andromeda, the two biggest galaxies in the local group, will merge at some time in the next few billion years, and the resulting catastrophe will be devastating. Stars will be thrown out of the galaxy, others will be destroyed as they crash into the merging supermassive black holes. The delicate spiral structure of both galaxies will be destroyed as they become a single giant elliptical galaxy. Although this may sound catastrophic, it is actually a normal aspect of the evolution of the galaxy. For a while now, astronomers have been aware of this upcoming collision. Our galaxies and Andromeda's trajectories and velocities provide the basis for this. The most crucial thing is that astronomers observe frequent galaxy collisions when they gaze into space. The Milky Way is far smaller than the Andromeda galaxy, which is speeding toward us at 68 meters per second. They will eventually merge to form a single massive spherical galaxy, which will take roughly 6 billion years. The supermassive black holes that are found at the centers of the Milky Way and Andromeda will also merge in this new galaxy, which is also referred to as Mila. Even though we've known about the Andromeda-Milky Way collision for centuries, it still feels unreal. In the early 1900s, astronomer Vesto Slipher foretold that the Milky Way and the Andromeda galaxy would collide. Many researchers have since used simulations to try to predict whether or not these galaxies would actually collide. Then, in 2012, scientists made a startling revelation. They had been using Hubble to meticulously track the Andromeda galaxy's pace and had found that it seemed to be heading almost directly toward the Milky Way at a speed of 68 meters per second. The two galaxies were predicted to collide in approximately 4 billion years, resulting in total mayhem. Even when the galaxy has died out, our solar system will still be around. Even while it won't be a red giant star yet, the sun will have become so intense that it can roast Earth's surface. Nonetheless, the universe has some very spectacular dances in store for any remaining forms of life. The current distance between the Milky Way and Andromeda is 2.5 million light-years. Gravity is pushing the two galaxies together, and they're traveling at a speed of 250,000 miles per hour. Their eventual rendezvous will not occur for another 4 billion years. As a result of their collision, the two galaxies will go through it, creating gaseous, starry tendrils as a backdrop. According to host Neil deGrasse Tyson, astronomers can confidently predict that the Milky Way and Andromeda will merge in a few billion years using only Newton's equations of gravitation. Due to the vast disparity between the sizes of the stars, very few, if any, stars in either galaxy will ever collide. Even though those faraway worlds shouldn't be in any danger, they are in for a spectacular light show that will keep on going for a billion years. How on earth can we possibly know that this will happen? In the early 20th century, astronomer Vesto Slipher calculated the radial velocity of the Andromeda galaxy, which is the pace at which the galaxy is moving in relation to Earth. Slipher was able to do this by analyzing the Andromeda light that reached Earth for any discernible compression or stretching. As things move farther away from us, their light is somewhat bent or redshifted. Objects approaching us have had their light compressed or blueshifted. Unexpectedly, it was the result Slipher stated in a Lowell Observatory bulletin in 1913. We may conclude that the Andromeda Nebula is approaching the solar system with a velocity of around 190 meters per second. At the time, astronomers incorrectly classified Andromeda as a nebula since they didn't realize it wasn't part of the Milky Way. However, Slipher's calculations provided compelling evidence that this incorrect classification needed to be changed. At least at this stage, Andromeda was clearly moving towards us, but whether its approach would spell the end of the Milky Way or for a long time, it was unknown whether the two would collide head-on or if they would sail past each other like star-filled ships in the cosmic blackness remained an open question. Discovering the lateral motion of faraway objects, or their proper motion as astronomers call it, is far more difficult than finding their velocity when they are moving toward or away from us. It becomes more challenging to measure the sideways velocity of an object at a distance because it doesn't produce the observable stretched or compressed wavelengths that astronomers use. Instead, they depend on careful observations of the object's position relative to the background stars. And without stronger telescopes, it could take centuries for this minute change to become detectable. Using calculations of Andromeda's proper velocity, Slipher and his former postdoc T.J. Cox simulated the upcoming collision and merging of Andromeda and the Milky Way. Their calculations indicated a higher-than-average likelihood of a collision between the galaxies, with the Solar System likely being thrown to the periphery of the new elliptical galaxy. The 2012 redo of the collision calculations was carried out by a team of astronomers from the Space Telescope Science Institute using exact measurements of Andromeda's proper velocity. The measurements were finally collected by means of the Hubble Space Telescope and an observation campaign that drew on years of data, beginning with photographs taken in 2002. Astronomer Sangmo Tony Sohn explains, "We compared Hubble Space Telescope images taken at various times and measured how much the Andromeda stars have moved relative to the galaxies in the distant background. The velocity at which the Andromeda stars moved across the sky is shown here. The team determined that Andromeda's proper motion was quite small, which meant that a head-on collision was almost inevitable. When the Andromeda galaxy and the Milky Way collide, the resultant changes to our solar system will be profound. Experts predict that the impact will cause the Sun to enter a new region of the Milky Way. Interactions between galaxies, particularly between giant and satellite galaxies, are common and occur frequently due to galaxies drifting too near to each other, attracting one of the main spiral arms of the other galaxy. This is held together by mutual gravity and the fact that galaxies orbit around a common center. In other instances, the satellite galaxy's trajectory may bring it into collision with the giant galaxy. If both galaxies lose enough momentum to continue moving after the collision, the smaller galaxy will be absorbed into the larger one, while the larger one will stay mostly intact and keep its shape. It is thought that Andromeda has collided with another galaxy at some point in its history, and such collisions are not uncommon. Earth and the rest of the solar system are not predicted to be entirely annihilated, but they will be pushed farther from the galactic center than they are right now due to the formation of new stars and the rearrangement and propulsion of gas and dark matter into different orbits. As previously stated, the Milky Way and Andromeda will not fully collide for another 2 billion years, as calculated by NASA using data from the Hubble Space Telescope. However, subsequent research has shown that the collision had already begun as recently as 2020. Even though they are still 2.5 million light-years apart, the Andromeda galaxy, the closest spiral galaxy to the Milky Way, is not visible in our night sky unless you look for it without optical aid.